Assalamualaikum and warm greeting to everyone. We are Group 2 from Engineering Economic course KUK 2142. In this presentation, we will be discussing how to estimate the bare module cost non-base for pumps and compressor based on the most recent cost data and engineering practices. We hope this presentation gives you a clear understanding of the cost estimation process using reliable methods and tools. Before we dive into the topic, let us quickly introduce our team members. First up, we have Utami Melia Ayu from Faculty of Electrical Engineering with student ID EL22108. Next is Keja with student ID AA22089, representing the Faculty of Civil Engineering Technology. Then, we have Nurul Azira with student ID AA22140, also from the same faculty. So yes, civil engineering is well represented in our group. Joining her is Nur Faiza with student ID AA22141, again from the Faculty of Civil Engineering Technology. And finally, we have Siti Nur Nazifa with student ID EL22081, who is also from the same Faculty of Electrical Engineering. That's all our team, a good mix of electrical and civil engineering students working together on this project. Next, let's move into the objective and the outcome projects. The objective of this presentation is to explain the methodology and key factors used in estimating the bare module cost on base of pumps and compressor in recent years. We will also highlight the main cost driver and necessary adjustment involved in the estimation process. By the end of this presentation, students should be able to understand steps and important consideration for calculating non-base bare module cost, which is crucial for achieving accurate cost estimation in real engineering projects. So, what will exactly we will cover in this topic? Let's take a look at the presentation outline. So, this is the outline of our presentation. First, we have introduction that will be explained about the definition and brief description of the topic given. Next, we have main topic that will be explained about estimating bare module cost for non-base. Next, we have subtopic 1 that will be explained about estimating bare module cost for non-base case for evac of pressure, for vessel and other equipment. Next, subtopic 2 will be explained about estimating bare module cost for non-base for evac of material. Same for exchangers, vessel, pumps, and other equipment. We have also example of scenario for question 1 and question 2. And lastly, we have conclusion for the summary of the topic. For the next part, it is introduction, which will be explained by Nurul Azira.
Thank you, Melia. So, what exactly is the bare module cost or CBM? The bare module cost CBM is the total cost of a piece of equipment. It's including in two terms, which is direct cost and indirect cost. For direct cost is material and labor. For indirect cost is engineering and overhead. But excluding auxiliary system, the non-base CBM adjusts the base cost for factors like materials type, design, pressure, temperature, and current market conditions. Now, let's go into how we estimate the bare module cost for equipment under non-base condition. We use the symbol CBM, which stands for bare module cost. This applies in two main situations. First, when the equipment is made from special materials like stainless steel or titanium. And second, when the equipment is used at non-ambient temperature, for example, like very high or very low temperature that are not standard. So, to calculate CBM in these cases, we use this formula. CBM naught equal to CP naught times with B1 plus B2 times by material factor and material factor. For equipment that is made from other material of construction and operating at non-ambient pressure, both FP and FM value are greater than 1. Next, let's look at one of the main factors that affect the bare module cost under non-base condition, and which is the pressure factor. There are two categories we need to consider. The first one is for process vessels. This formula is applied to both horizontal and vertical vessels. In this formula, we insert the diameter and pressure in bar unit. There is some condition where we set the FP value to a fixed value. For example, if the diameter of the vessel is lesser than 0.0063 meter, the FP value will automatically be 1. For pressure less than negative 0.5 bar, the FP value will be 1.25. For other equipment other than vessel like pumps or heat exchanger, we will use different FP formula. As we can see here, the formula involves C1, C2, and C3 constants. This slide is showing where we can obtain the value of C1, C2, and C3, which is available from table A.2. That's all from me, and I will pass to Kisha for the material factor explanation.
Thank you, Ira. Hi everyone, I'm Keisha, and in this section, my concentration will be on the artwork of understanding how the equipment influences the price of the bare module when it is said to differ from the base material, and also showing how this is made effusive through the material factor FM. In the area of engineering economics, in order to estimate the equipment cost, the point of reference is relied on a base case, where the baseline is most often that the equipment is constructed, which is often carbon steel. Materials other than carbon steel are also often necessary in industrial applications. At conditions which raise the temperature, pressure, or chemical reactivity, it is often necessary to specify the materials such as stainless steel, titanium, or nickel alloys, which cost more than that of carbon steel. This is where the material factor FM comes into the picture. It operates as a multiplier to represent higher cost if equipment is produced from some other materials than those assumed in the base case. In the main, it implies the extra cost that is associated with the use of anything other than carbon steel. The requirements are in table A3, lists several types of equipment including heat exchangers, pumps, and vessels, in which specific material can be used in each. For each of the equipment and its material pairing, there is an assigned FM value. They are based on real cost data and also on engineering resources. Figure A18 demonstrates that these materials factors with the FM values on vertical and equipment identification numbers from table A3 on the horizontal. Obviously, there is a considerable discrepancy between the FM values. The FM figures close to 1 tells us that the material is nearly as costly as carbon steel. At the upper end, FM values can be greater than 11 or even 12, implying that the material price could be substantially higher than 10 times that of carbon steel. This explains the reason why selection of the right material is critical for accurate cost estimation. Then, table A5 will serve to guide when equipment types are not indicated in table A3. In table A5, you will list the equations that will be used to determine the bare module cost, which allows the use of FM and correction terms such as FP for pressure, FT for temperature, or FQ for quantity, especially when dealing in trays and also packings. This approach allows us to use a consistent estimation of the cost with regard to many equipment types, in spite of the fact that for some of them we may have precise data. Similar to table A3, the table A6 also portrays the equipment type, equipment description, and the material of construction for the said equipments based on the identification number. Ultimately, in a material selection context, especially with regards to plant design and analysis, it is not sufficient for us to pick a material solely for technical capabilities. In decision making, economic considerations are very important. If the use of a more durable or safer material adds a lot of cost, then we must decide if the added expenses does indeed pay. Ignoring FM in cost estimation would be an error since its incorporation is a must for engineering decisions that are realistic and financial wise. So now I shall pass the baton to Ifa for the next slide. Thank you.
Thank you, Kisha, for your explanation. Now I will proceed to some example scenario for bare module cost for non-base. For question 1, estimate bare module cost for a centrifugal pump in 2025. A centrifugal pump with a shaft power 100 kW is planned to be installed in 2025. Based on available purchase cost curves and assuming a material factor and pressure factor of 1.0, estimate the bare module cost using the Chemical Engineering Plant Cost Index. Given that for 2025 is 750 and the base cost data is from the year 2001 is 397. Determine the adjusted CBM for the current year. So the question asks to find the adjusted CBM for the current year, which is in 2025. To solve this question, we can use the bare module cost equation CBM equal to CP0 times with B1 plus B2 times FP and times FM. This formula is on the page 26 in the handbook. In this question, the value of FP and FM has already given, which is equal to 1. The value of constant B1 and B2 can be found in the tables A4, which was on the page 29 in the handbook. From this table, the B1 value is 1.89 and B2 is 1.35. Next, to find the value of CP, we have to use the equation log 10 CP not on the page 5. To use this equation, we need to find first the value of K1, K2 and K3 on table A1 from page 6 until 9. From this table, we get the value of K1 equal to 3.3892, K2 is 0.0536 and K3 is 0.1538. A is referring to the capacity of the equipment, which in this case the value of A is 100 kW. By inserting all this value in the formula, we can get the CP is equal to $41,893 and $34. After we get CP, which is equal to $41,893.34, to find the bare cost modules for the current year, we need to use the cost index given. For the year 2001 is 397 and in next year for 2025 is 750. So, to find the CBM for the current year, C 2025 equal to C 2001, which is $41,893 and $34 times with the 750 divide 397, and then we can get the CBM for the current year is $79,143 and $49.
Alright, thank you Faiza for the detailed explanation. Now, let's take a look at another example of question that require us to estimate the bare module cost of a compressor. So here is the scenario. A rotary compressor made of carbon steel with 600 kW fleet power is to be installed in 2025. Estimate the bare module cost for the compressor. Use the best purchase cost from 2001 and adjust it to 2025 by using SAPC. Given SAPC for 2001, 397 and SAPC for 2025, 750. Assume that the material factor and pressure factor is equal to 1. Different to the previous example, the calculation used to find the bare module cost for compressor will be using different equation. The equation is CBM equal to CP0 times with bare module factor FBM. This equation can be found on table A.5 on page 29 in the handbook. Firstly, to find the value of CP, we need to use the equation log 10 CP0 from page 5.
To use this equation, we need to find the value of constants K1, K2, and K3 from table A.1. A is referring to the capacity of the equipment, which in this case, the value of A is 600 kilowatt. Inserting all these values in the formula, giving us CP0 is equal to 2,535,363.08. Next, we need to find the bare module factor FBM. The FBM value can be found by referring to the graph on page 30 in the handbook. But before that, we need to identify the identification number from table A.6. From the table, the identification number for rotary compressor of carbon steel material is 7. The CBM value is equal to CP0 times with bare module factor. From the calculation, we get $6,084,871.39. To find the CBM for the current year, we need to use the SAPC. Given the index 2001, 397 and 2025, 750. By inserting the values we have, we obtain the bare module cost equal to $11,427,338.90. Now, we already knew how to calculate the bare module cost for both pump and compressor. And now, for the last part, I will let our friend Melia to conclude this presentation.
In conclusion, understanding and applying engineering economic tools is essential for accurate cost estimation. First, the cost-based method or CBM is fundamental in engineering project, as it provides a structured approach to estimate cost based on actual component prices and industry data. Second, to ensure that cost estimate remain relevant over time, we use the Chemical Engineering Plant Cost Index, or we call it as the CAPC. This index allows us to adjust historical cost data to reflect current market conditions, maintaining accuracy despite inflation or economic shift. Lastly, when estimating the cost of specific equipment like pumps and compressor, we follow standard industry multipliers. These multipliers are divided from historical cost relationship and industry benchmark, helping us to estimate bare module cost efficiently and reliably. Together, these tools, CBM, CAPC, and industry standard multipliers, form the backbone of precise and up-to-date engineering cost estimation. So, thank you for watching our presentation. We hope it has been informative and helpful in understanding in cost estimation process for pumps and compressor. Bye-bye!